So, in today's episode, we're going to be looking at the idea of intercepts, and this has briefly been touched upon in previous episodes this season. However, we're going to look at them in a bit more depth today, and actually look at how we can use them in our calculations with linear algebra. So, intercepts can be useful for a number of contextual reasons. That's why it's important to be able to know the mathematics behind them. And in case you've forgotten what intercepts are, we have a linear equation on the board that's on the Cartesian plane, and we have an x-intercept where the equation cuts through the x-axis, the horizontal axis, and we have a y-intercept where the function cuts through the y-axis, which is the vertical axis. And an intercept is simply when they pass through either one of those. So we have one x-intercept and one y-intercept on our actual linear function. But here's something very important to note that can really help us with our calculations. At the x-intercept, y equals 0. And you can probably see this if you have a Cartesian plane in front of you. When you're looking at it cutting through the x-intercept, y is going to be equal to 0 along this line. And the same sort of logic applies for the y-intercept too. So, at the y-intercept, x equals 0. But now let's have a look at a few questions associated with intercepts. These are just basic procedural questions that will help you understand how to find the coordinate points which exist for these intercepts. Determine the coordinate of the y-intercept. And it's not given as a function, so it's just asking us really for a general form here. So we know that the general equation for a linear function is y equals mx plus c, where m is the slope and c is the y value y-intercept. So what we can say is that the y-intercept coordinate is going to be equal to 0 as the x and c as the y in terms of a coordinate point. So, using that logic, if we were ever asked to find the y-intercept and we were given an equation like that, maybe it's 5x plus 4, for example, we can easily substitute it into that general form. But then, what if we were asked for something slightly different? What if we were given the equation, 7x take 8, and it wanted us to find the x-intercept, for example? And this is where we have to start using these rules that we covered before. Now 7x take 8 was also a function that we looked at previously a couple episodes ago, so if you're interested in how we actually found that equation, we did it when we were looking at the equation of a line. But what we do with y equals 7x take 8 is we actually substitute in y equals 0, because y equals 0 at the x-intercept. We can see that if we look at the Cartesian plane. So 0 equals 7x take 8, and now it's just a matter of algebraically rearranging to isolate x. So we move the 8 to the other side. By doing so, we're essentially adding 8 to both sides. Negative 8 plus 8 equals 0, and then 0 plus 8 equals 8. So we end up with 8 equals 7x. So therefore, what we do is, because we have 7 on this side and we want to isolate x, we move 7 to the other side. And because it's in the numerator on the right-hand side, it's going to be in the denominator on the left-hand side. And as a result, we get x equals 8 on 7. So what this means in terms of the x-intercept coordinate, we have an x-intercept at this coordinate here, where x equals 8 on 7 and y equals 0. Thank you for watching. Join us next time. However, if you need more practice or more support, check out our apps on the App Store. They have great worked examples, they have incredible worksheets and other materials that can help you really ace exams. We have Formulae for iPhone and Formulae for iPad. Also check us out on Twitter and Facebook to keep up to date with all the educational material that's coming out. Thank you.